We'll explain how we have modeled this tower following this specification. This panel is named KMH. KM model. We've used this panel to design this tower. Our first panel height is 10 meter, and following this drawing we have prepared the model. This is KMH panel, this is also KMH panel, this is half KMH panel, then this is M panel, and we have followed this rule. First we have used KM panel, this is half of this. Then in the next panel we have used inverted KM panel. Inverted is a new term. If we want to use a panel which is similar to inversion of this main panel, they can use this term to make the panel inverted. So this is inverted, this is actual KM panel, and this is inverted KM panel. Then this panel, it is KM also, which is this, and this is inverted KM, this is actual KM, and this is M panel, M1 panel. This is M1 panel. And after that all our panel are easy, which is XH3A. This is the full XH3A panel. XH3A panel. We have taken the panel height from this drawing. Ten, 20, 29.6. And there are total 11 number of panels. We have also 11 number of panels, but we have made one extra panel which height is 0 to make the top portion. This panel, this height is 0, every part will be 0, only the plan PB1 will be a member. This is how we have made the panel, and we have assigned section property from here also. Here section property have been given. Leg section is star on 51 by 12, and all section has given here. We have followed this drawing, and we have some knee bracing, view FGH IJK. Knee bracing has been detailed and given here, and we have plan bracing also, section A, B, C, D. This is C, this is B, and this is A. We have followed this full drawing to make our model. Some section has given here as well, A, B, C, D, F, G, which have been used here and also in plan bracing. This is how we have made the model, and for load we have followed the load part 3 tetra antenna at 75. We have followed TI22G code. Wind speed is 50 and class G G50, structure class 2, exposure C, topography 1, topography 1, class 2, and TCAT 3. Terrain category, topography category 3, terrain category 3, structure class 2, and exposure category 3. We have made the load combination and basic load case here, and here we have used the antenna. We have a GSM antenna at 70 meter. We have GSM at 70 meter. We have GSM at 70 meter, and we have put this 6 GSM at 70. We have another 6 GSM at 67. Which we have used here, and we have 1, 2, 3, 4, 5, 6, 7, 8.6 at different level. We have also put this here. We have 3 tetra antenna, 2 omni, 2 dipole. Three tetra, 2 dipole, 2 omni. We have WiMAX, 1 WiMAX, 4 WiMAX. It will be fact 4, and we have some proposed antenna also, 6, 8.6 and 3 GSM. We have placed 8.6 and 3 GSM antenna. We have feeder and a cage ladder from bottom to top, and we have used antenna cable for this. The GSM antenna has been defined in the GSM tetra and omni dipole antenna has been defined in the ancillary library. File, configure, ancillary library, programs. We'll use this antenna here. Tetra. We use tetra antenna, AF 1.3, ASF 1.3 meter square. We have taken these values from previous analysis of this company. they have used the HE panel as 0.49, which we have used in GSM, quantity of GSM. Here's a GSM antenna, and we have used 1 meter square is the basic load, because they have also used 1 meter square for their GSM. This is the GSM. They have used 6 meter square for GSM. We have used 1 for 1. Then we have used tetra antenna. We used 1.3 and 1.3 frontal area, force area, side force area, and they have used tetra as 3 tetra 3.9, so 1 will be 1.3. We use Ymax as 0.18, 0.093 from these. Ymax, the dimension of the Ymax is 100, 650 and 200. We have input these values and the force came here. This is in feet square, and we have changed to its meter square. So it's finally 0.18 and 0.093 is frontal force and side force. And we have used Omni antenna. The Omni antenna 0.40. We have also used these values directly, and they have used dipole antenna 30. Control F DIPOLA dipole. Dipole. This is our dipole. They've used dipole 30. We have to use dipole 30. Our dipole is 15 for 1. And our Omni will be namely 40. As they have used this 40 value, Omni 40 40. For one Omni there is 40. We are using also 40. And we have used their GSM antenna force, tetra force, dipole force as they have used here. so their force and our force is same. Now we'll make the analysis. There is no error or warning. It's a report that this section is horizontal, this is basing. So it's not a error report, it's a report, build report. This star marks means this member has been failed, and this hash marks means they have failed in KL over R ratio. So at bottom our leg has passed but our bracing has been failed. At second panel our legs have passed but our bracing has failed. This panel number is 22. So if we go through every panel we can understand that which member has been failed and which member not. Now we have to increase this member size and rerun it and make all the member passed from here.